Hello, in this presentation I am going to talk about a recent book we published titled Wireline Formation Testing. We cover hardware, pressure transient testing, interpretation, and sampling. So I'm going to use WFT for wireline formation tester. First, let me introduce my co-authors, T.S. Ramakrishnan with Schlumberger and Mustafa Onur with University of Tulsa. This book is available through Amazon. Here is the website, and also through SPE website, Society of Petroleum Engineering website. If you are a member of SPE, you will have 50% discount when you are buying the book. Wireline Formation Testing book introduces hardware interpretation theory and methods for wireline formation testers. Naturally, the methods fallen within the principles of the pressure transient analysis, with nuances such as static and dynamic data acquired at multiple depths along the wellbore. The pressure gradient data from formation tester provides in-depth information of the formation fluids. I am an emeritus fellow geoscientist and was a Schlumberger fellow and a chief reservoir engineer. Worked in the United States, France, and Dubai. Retired from Schlumberger after 35 years with the company. I was a consulting professor at the Petroleum Engineering Department of Stanford University from 1988 to 1994 and taught advanced well testing. I am a distinguished and honorary member of Society of Petroleum Engineering Engineers and Society for Industrial and Applied Mathematics, the Russian Academy of Natural Sciences, and the American National Academy of Engineering. Receive a number of awards from several societies and institutions. I author and co-author few books, more than 150 papers in science and engineering journals. When a well is drilled, we run several open-hole logs. These may include gamma ray, caliper, resistivity or conductivity, borehole imaging, density, sonic, nuclear, magnetic. We run a wireline formation tester and/or well testing based on evaluation of these logs to acquire formation, pressure, and take fluid samples. Reservoir properties determined from the petrophysical analysis of open-hole logs and geological interpretation of seismic data are used to build geological model to design and interpret pressure tests for reservoir characterization. A reservoir is a spatially three-dimensional geological body that contains three phases: gas, oil, and water, on which three forces act, namely gravitational, capillarity, and viscous drag forces. These forces are the essence of single and multiphase flow in the formation porous media. The rate change, injection or production at the surface or subsurface creates pressure diffusion we call transient, in porous and permeable formations. As production continues, pressure diffuses away from the wellbore deep into formation that brings information about the properties and characteristics of the reservoir. Pressure transient formation tests for oil and the gas exploration and production and for the injection wells are the most powerful tool for determining well and reservoir parameters under dynamic conditions. Because of their dynamic and direct, pressure measurement provide essential information for well productivity and dynamic reservoir description, and hold critical importance for exploration as well as production and reservoir engineering. The science of interpretation is founded on inference, and thus it is uncertain. It is therefore rely heavily on experienced individuals. This book uses mathematics, geosciences, and reservoir engineering to formulate and solve interpretation problems, for which mathematics provide us a powerful theoretical and computational techniques for advancing transient pressure test interpretation. The first wireline formation tester was introduced in 1957. It was not a very successful tool. Second one was introduced in 1970, known as Repeat Formation Tester, RFT. It was successful in acquiring reservoir pressure along the wellbore. Downhole samples were usually mud filtered, so we couldn't take the oil and gas samples. Since 1990s, formation testers have advanced substantially with improved pressure gauges. Here we see the RFT, or repeat formation tester. As you see, at that time quite complicated tool and also a very good tool. But if we look at today, it's a very simple tool. Here we see modern wireline formation testing tool. So it has many modules, power modules, sample bottle modules, sample pump modules. We can pump fluid in and out from formation. And a fluid analyzer, we can analyze fluid downhole to obtain several properties. And hydraulic module to do a lot of hydraulic functions. We have focus probe to have uncontaminated samples. And then we have another fluid analyzer and then another pump. And also we can add Packer module, single probe on top of these configurations. So quite involved advanced tools, and today that we have. So these tools acquire formation pressures very accurately. Pressure gauges are very accurate today, and conduct pressure transient tests both from Packer and probe, and also with additional observation probe we can conduct vertical interface tests. So we acquire representative samples with very little mud filtrate contamination. We can do downhole composition analysis. We can conduct formation stress tests, and we can inject fluid into formation and into wellbore.